Okay, so I was looking at the next thing to look at, which was trees, tries, also called prefix trees, and they're often used for storing languages and like words, and you can store a lot of words because it's really efficient. So we're gonna try to build a try. Okay, I'm gonna call this try.js, and we're going to look at what that looks like, and it is. Now I'm curious about like how I would implement this, because it's basically just like a node that references to many other nodes, right? So I think I just want to make a node here, and went to constructor, some val. In this case, I'm actually going to make this a letter, and this dot letter equals letter. Okay, and then this dot next equals null. And that is effectively it. And then I will create another class called a try. Oh, I did it. Okay, constructor. I won't have it have anything, because the idea here is that it will add words to the base structure, but it needs to keep track of a root. A root is going to be a new node. New node, which will be basically empty. So this is going to be just a starting point. So so the idea here is we're going to add words to this root, and we'll have to like check to see what the children's values are. So I think there's going to be some more functionality in this node actually, because I want it to check its children. Oh, so this dot next isn't quite next then. So I could use a array. I could use. Should I just do that? Children? Like this? I think it's fine. Like I'm just kind of trying to work it out. If it doesn't work, I'll change it up later. Yeah. So you have the root, which will have basically all the children being the first letter of the word, and then those children will have their own children, which will be the second letter, and so on and so forth. And then the way I want to end it with is with a flag, or not a flag, but a star or something, some kind of like a node that says I'm not a letter, I'm just the end. I recognize that I'm the end of the string. Anyway, so this is what it's going to look like. We're going to have to add a word. We're going to have to look up a word. And I think that might just be it for now. I think that's going to be complicated actually. And let's do that then. So let's look what that. I kind of also like the idea of like just coding or writing out the code that you want, and then you kind of code it out later. So the way I want to have it with my tray is a new try right there, and I want to add the word I don't know, computer. I'm so original, and I should be able to console.log root, t.root. Ideally, I would do lookup here, but I'm just looking at the raw data at this point. So let me do this add new word. So this is a word. So it's gonna be some kind of string, and right now I just want to do nothing. So I will see if it runs. Let me clear this. Did I put you in the wrong spot again? Yes, of course I did. Happens way too often. Let me just pull you up here. Yes. Okay. All right, cool. There we go. So we have a letter undefined, which is the root of it, with no children. Okay, cool. So let's add a word. So how do you add a word? Oh boy, it's going to take the first letter, so I can do a for loop. So I want to do like the root, let current node equal this dot root. So that will always be defined, so I don't have to worry about that. Can I do letter in word? Is that, no, it's of word. So here we go. I have to add this. So I need to first check, does this letter already exist? If it doesn't, then I'm going to create a new node and then add it to that, as a child to the node. So that's actually another thing. So again, I'm going to write code that I wish I had. So if cur dot has letter, I want to give the letter as argument, and I simply need to get that letter. Cur equals cur dot get letter node, and I provide the letter. Okay, so this clearly means I need to have these methods already in my node. So I want the responsibility to be the node, to actually know how to handle its own children. I think that makes sense in terms of responsibility. So you node should know your own children and should be able to handle your own children. you should handle your own children. Okay, has letters. This will literally just like return this dot children. I think you can do. Oh man, it's been a while since I've done JavaScript methods. I think you can do some. Let so node dot letter equals letter, then it will return true, I believe, and then for get letter it will literally return this dot children dot find node where node dot letter equals letter. I think that is how that works. Let me do something real quick. And I want to kind of play with my own API here. I think you do dot load JS try.js. Yes, that does work. Okay, letter is not defined. What? Okay. 24. Saying here letter is not defined. Letter of word. Oh. Let? Is that what you mean? Okay, it seems like that worked. Yeah, it was. So I need to put the const here. Why that didn't work before in the environment, I don't know. I don't know, but whatever, it works now. Okay, cool. So I can. Oh wait, did I? Oh, it implemented this. It ran this already. So, but I didn't implement like what to do with it here. Once you get this, you should like. So if you have the letter, then you're done. Else, if you don't have the letter, then you need to add it. So it needs to add. Okay, cool. Right. Okay. So what am I thinking about? I want to test to see if these things worked, and I think they do actually. It's kind of hard for me to test it out right now because I need to create a. Well, I guess T is already created, and me adding it doesn't work yet. So I need to attach to the root. Children.push new node that is the letter A. It returned 1. Does push return? Okay. C.root. Children. Letter equals A, and it doesn't have its own children. It is okay. So this is an array of nodes, and this is the first node with the letter A with no children. So it doesn't have any of its own children. Okay. So adding did work. Or no, I just added it. So now I need to call a method, which is t.root, which is .get, or which is has letter. Do you have the letter A? True. Do you have the letter G? False. Perfect. Okay, so it is working. Get letter node. I want the letter A. Give me the node. Bam. Give me the letter node for G. It won't. It'll give you undefined because find will give you undefined. Okay, fair enough. So they're working basically. So yeah. So one thing I'm now considering is, like I said, my implementation will have some non-letter character to signify the end. So now I have to like keep that in mind that if that letter shows up, that means you hit the end. So I'm thinking like in terms of like system design, like I want the tray to have a constant that's like the special character or end character, which equals, honestly, it could be anything, right? Because it's just a value. Although I just want it to be like, fine, I'll just keep it like, it's fine. And then I will add this. And I think that makes sense. The try should have the responsibility of containing its, knowing its own special character for the end character. So that's why I'm tagging onto the class and not like the object, for example, because it's inherent to the class itself. I think that makes sense. I don't think you want. I don't think you should be able to like customize that, right? It's a constant. So I'm going to literally say word add this thing onto you. That way, that ensures the end character is there. If the end character shows, if you have that letter, then you're fine. Yeah, then you're fine, and you're done. And then now I need to add. Now, if it doesn't exist in the children list, now I need to just add it there. So I should do something like cur.children.push a new node that is the letter. And now, oh, actually, I should definitely keep track of that, because that is in fact the const new node equals that, and that is in fact the node that I want to have as my current. Yeah. Okay. Do I want to return anything? I don't think so. I think it just adds. Okay, so let me get out of this environment and let's start adding words, which I already have here basically. So let's look what you look like. Node my.js try. Okay, so here we see the children. C, which is in computer, the first letter in computer, is there. Not very convenient though, because it kind of truncates visually like what we're seeing here. So what I want to do is kind of visualize this a little bit more in this lookup word thing. So what should lookup word do? Just return true if word in try. But what I want to do, what am I trying to do? I'm trying to, I think what I'm trying to do is I'm trying to print the entire dictionary. So I need to do a depth first search, right? Do I need to go depth first? It's convenient to do depth first just because I want to print out the whole thing, right? Yeah, I don't need to like look at the values. I want to like go all the way to the end and then keep doing that. That might be a little bit more tricky, but that's what we're here for. So print, and that is the entire dictionary. And the way I do that is start with the root. And I mentioned before that I kind of wanted to do a queue, and I think I'm going to just kind of be lazy and use an array just because it's like easy to implement. So I'm just going to be lazy for a second. I will call it queue though. So I'm thinking like, how does the queue go? You got the first, so in that case, then you don't need this root thing because it's going to be just like the first thing in the queue is this .root. Right? So what I want to do, I literally just want to console log the string at that point. So maybe I have to keep track of the current word. And I have to, like, I grow that out and shrink it depending on where you are in the queue, I guess. Okay, cool. So do I need to, I'm not sure if I need this current word. I'm going to keep it for now. But I want to do a for loop, I guess. All right, a while loop. While queue.length, while you have a length, then keep going. I always spell length wrong, so that's annoying. So while you have a length, then the current, so we establish the current node, cur equals q dot pop, I think. Pop, let me see that. Pop removes the last element. I want the first element, so I think shift is the one. Removes the first element of the array. Fantastic. So it'll be the first in, first out. Or do I want it to be last? Do I want it to be a stack? No, I want it to be a queue. I think it's fine. So in this case, root is the first one, and we are looking kind of at the children actually. So const children equal cur dot children. And now you loop through the children. So if the children length equals 1 and cur dot find, what do they call it? Find has letter. And has letter, and this letter is try dot end character. Then you know that you are done. You can continue. So you don't need to do anything else, which is great. So that you just pop something off the end that didn't matter. But how do you keep track of all the letters then? I don't keep track of this. I don't keep track of this. I just keep let words. I can, or just word. Word storage. I don't know what to call it. But effectively, we go through each letter here in the children. So for let const child of children. So each child is a node. Okay, we are back. I need to keep my voice down just because I have people sleeping in the other room, so I'm gonna try and not talk too loud. But I was thinking about the solution for this, and I realized I need to pass. It would make sense to pass along the information in a recursive way, and that way you can actually get to have a complete set of the letters that came before each end of a word. So I'm going to actually create a helper function real quick that just kind of does that. I'll call it print, and it will take a string. This is like the previous string letters, and then the node, and this will actually do the printing job. So if I'm doing this correctly, then I'm going to check if no.letter equals try dot end character, then we will return with nothing. Yes. Okay. So this is my base case effectively. So there needs to be this end character at the end of every single word. All right. otherwise, I need to call for letter. So child of node.children. So that means any other situation if you're not at the end, then you will pass on. The default should be a blank, but at the end you should pass on the previous letter along with, so this dot print the previous letters along with your current letter with your child node. And actually, I forget, I don't return here, I just console.log the previous letters, because that is the word. I don't need to return anything. And then actually I will return here, just to end the logic here, because you're done. Okay. So now here, this is what I was trying to do here. So instead of doing all this, yeah, I don't think I need all of this, because now I have my logic all wrapped up in here. Yeah, I think I just provide the print with nothing and the root. Is that right? Am I crazy? Will that just work? Console log. I don't need console log then. I can just do t.print. Actually, I think I might not even need the whole helper function. Undefined computer. Fantastic. Undefined. Where am I printing undefined? I'm printing undefined because of the root that doesn't have its own value. So you need to in that case, then yes, you do need to do you need to do this for every root's children. It's fine. It's messy, but it's fine. So for const child, I want to say first letter of this dot root dot children, then just call print on that first letter. Okay. Just gonna finagle this a little bit. I don't need this at the very end, and I'm gonna put the node first. Okay. Alright, so let's see how that works. Hey, alright, doesn't work. Node.children. Node.children is not iterable. Am I calling it wrong? Hold on. Oh, I think I messed up. Yeah, I put this. Okay. I put them in the wrong order. When I changed these function signature, I needed to change it everywhere. Duh. Okay, that's fair. I think you're fine. Okay, one word is computer. Okay, cool. So that's working. All right, so just go through the logic here. This print function goes through each letter, each child within the root, which is basically the first letter of every word. Then it will call this helper function, which does this recursive call on itself that gets the entire word for every word, and it passes along the previous letters that have been accumulating up to that point. And then at the very end, it has this end base case, which prints out the whole word effectively once you get to the very end. So let's add a bunch of words here, right? All right, so let's put apple. Oh, Apple, phone, microphone. And just to be particular, apple and apples will be different words technically. So this will showcase the fact that the trie can actually have a word and then a word that's very close to it and then one off, which will have its own ending, unique end. So let's look at that. And it printed out exactly what I saw there. It's in the same order that it was in. So I could do some like minor tweaking here, where I could, I could collect all of the words and then put them in the alphabetical order. I'm curious if I would want to do that. I kind of do, because it's a dictionary, right? So two things. I could collect them, or when they are inserted in the first place, they are sorted. I think I prefer that more. It's more elegant, that the structure of the trie inherently has order to it. I don't need to like hack it effectively. So that means that whenever I add a letter to the children, that means I will want to have a method here. So I say add child, and this is going to be the letter of new child. Okay, and to do that, I will create a new node here. So const new node. This is a new node with the letter. Okay, and I could certainly add this. I think I just want to add it and then sort it. Literally, there's a function in JavaScript you can just like sort, and I want to do that. I think so. This dot child dot push new node, and then I'm just going to call this dot children. I mean children, not child. Dot sort. And I think it's like, okay, so node. So it's the way it goes is node A and then node B, and I want specifically node A to be node A dot letter to be less than. We'll look at it. We'll see how it works. Sometimes I get them confused about like which one goes first, but it's something like that. And that means I need to use this. I have to use this method anytime I want to add to the node. That means anywhere down here where I say push, I'm not pushing. I'm now going to add to it. And it looks like here I would like the functionality of returning that node itself, and I think I want to have that also. So when I add the child, I will return new node for that functionality. I don't. No one else should really be accessing this, right? Well, yeah, it's the API set up for just the wrapper, so I think it should be fine. Okay, yeah, okay. So the current is the current letter node. So it's really cur dot add. The add child, sorry. Okay. Add child with the letter. And then that will return the new node, and that will be resetting current to that new node. And I think that should work the same way. I don't think I'm calling append anywhere or push anywhere else on that as well, so that should be fine. Okay, let's see if that worked the way I wanted it to. So these should add properly. And of course it does it the opposite that I thought. I put A at the bottom, so I need to put the sorting to be. I swear I always get this one wrong. So I'm just going to change this to that. Okay, so that should organize it properly. So apple comes before apples, then C, then M, then P. So this is exactly working exactly the way I want it to. And I think I'm kind of done with this try at this point. And what's really, really nice about this is because of how the data structure is set up in this very compact way. You're kind of reusing letters anytime you see a word that has a similar path, effectively. You can store quite a lot of information in a very small space here. Commonly tries are used for like storing like the whole English language, and then you can quickly access things. And in the book it mentions that it's not quite constant time. It's effectively as long as the word, so it's O of k, where k is the length of the word. And that makes sense because the really long words will have to traverse more, which makes sense. So there is some it's not quite constant, but it's like freaking close. That's very, very close, considering all the words that exist and the fact that you can basically look it up in that very quickly. Until next time, bye.